Okay, now in this last video, we're going to talk about phase change. So remember, on the phase change diagram we looked at, there's actually two things going on that diagram. Not only phase change, but also temperature change. And remember, they can't happen at the same time. We've already talked about temperature change in a previous video. This one's about phase change. So there's another equation that governs phase change, and it's Q equals mH. And that H is going to have a subscript on it, either V or F. So a couple of similarities but with Q equals mc delta T. First of all, both require thermal energy. I have to put thermal energy into water to heat it up. I also have to put thermal energy into ice to melt it. That's a phase change, a change from a solid to a liquid, liquid to a gas, or vice versa. Those are phase changes. But phases are solid, liquid, and gas. The phases are states of matter. So it still requires heat to do a phase change. You either have to add heat or remove it. It's just that in this case, the temperature is not changing during a phase change. Notice temperature is not a part of this equation. Also, mass is a big factor in this. You have to put more energy into 10 kilograms of ice to melt it versus 1 kilogram of ice. So the amount of heat required to do a phase change depends on the mass of the substance you're trying to change the phase of. And then let's talk about HF and HV. So HF is called the heat of fusion. And when you think fusion, I want you to think freezing, because this is the heat that has to be removed from any substance to freeze specifically 1 kilogram of it. So we're talking about joules per kilogram. So if the HF is 100 joules per kilogram, let's just say it's ice, which that's not the number, but if it is, that means I have to remove 100 joules of heat to freeze it. Now, out beside this, let's see if I can write it to where you can read it. Let's do a yellow. I want you to write this. Freeze. Horrible writing, I know. Freeze slash melt out beside that, because you need to know that the heat of fusion applies to both of these phase changes. We talked about on the phase change diagram that there's only two phase changes. There's freezing, melting, and there's vaporization and condensation. They just have different directions. Remember, when we freeze something, we're removing energy from it. When we're melting, we're adding energy to it, but it's the same phase change in opposite directions. So any problem that deals with freezing and melting, we're going to use HF, the heat of fusion. And then HV is called the heat of vaporization. And then out beside this one's going to take longer to write. I want you to write, maybe I'll abbreviate it, VAPOR period, stands for vaporization, vaporization slash condensation, COEDENDS. There we go. Vaporization, condensation. Can you read that? That's an N. So this is the heat that has to be added to vaporize or boil 1 kilogram of a substance. And again, vaporization and condensation, they're the same phase changes. Vaporization is adding energy. Condensation is releasing energy. Same phase change, opposite directions. So any problem involving vaporization or condensation is going to be any problem involving vaporization and condensation, we're going to use the heat of vaporization, and I'll tell you where to get that in just a minute. Okay, I want to help you learn how to solve any temperature and heat problem. So there's going to be a big flow chart on this page. If I were you, I would find some blank space, a significant amount of blank space, like a blank page, piece of notebook paper, and I want you to copy this flowchart. This will help you understand how to make decisions about how to solve problems involving temperature and or heat. So the first decision you have to make when you encounter a temperature or heat problem is remember that page 15 was broken into two parts. It's either temperature change or it's phase change. You cannot have both at the same time. So that's the decision you have to make, and we'll talk about how to make that decision, but it shouldn't be too difficult. You got to decide whether the problem's talking about a phase change or whether it's talking about a temperature change. If the problem is about temperature change, then it's fairly straightforward. The equation is Q equals mc delta T. That is our temperature change equation, and that's easy to see. Delta T is change in temperature. Remember, C is specific heat. So when you go to the chart when you go to the chart, oh, right here, let me get rid of that. When you go to the chart and you're looking at all of those values, the specific heats only come into this equation. You don't need heat of fusion, heat of vaporization for this equation. Specific heat is only for temperature change. But on the other hand, if it's about a phase change, if the problem is about melting, freezing, vaporization, condensation, you actually have another decision to make, because you have to decide whether the problem's about the melting, freezing phase change or the vaporization, condensation phase change. It's not always going to be exactly clear, but there's definitely going to be enough information for you to make that decision. If it's melting or freezing, the equation is Q equals MHF. We're using the heat of fusion for this problem. And so again, no specific heat here for the phase change problems. It's going to be heat of fusion for this one. If it's vaporization or condensation in the problem, it's Q equals MHV, HV for vaporization. And again, both of those are in the chart. I also want you to circle these three right here, the C, the HV, and the HF. I want you to circle those because these are constants. These are the constants that you will have. A constant is a value that stays the same, at least for a certain material. If a problem is about water, that's what this is. If a problem is about water, these values are going to be found in the chart. So if you look at the equation chart down at the bottom right, you'll see a section that says constants. And you'll see specific heats down there, heat of fusion and heat of vaporization for water only. So if the problem's about water, you're going to need to go to the chart to get those values. So have this handy as we go through some of these problems, and it'll help you to see how to do them. All right, so let's look at these two problems down here. Again, remember your flow chart that you wrote down. The first question is it a temperature change or is it a phase change? And we can see if we read this one, how much heat energy is required to heat 0.3 kilograms of water from 20 to 30 degrees Celsius. This one is a temperature change. And it's not a temperature change because it says heat energy. Heat is also required to do a phase change as well. But it's a temperature change on this one, I know, because it says two temperatures. It gives us two temperatures. Problem might also ask you for the change in temperature. If it asks you for the change in temperature, that's delta T, and it's definitely a temperature change. So you'll be able to see whether it's a temperature change or not. The second one here, how much heat must be released from, so actually, temperature change, Q equals MC delta T. The second one says how much heat must be released from 1.2 kilograms of paraffin wax, and it gives you a value there to freeze it all. This one, if you notice, it doesn't give us any temperatures, and it might, but if it gives you a temperature, there will only be one of them, because at a phase change, which is what this is, the temperature doesn't change, so there's only going to be one temperature. And in fact, temperature doesn't come into this at all. So if you're given a temperature, like for instance, this problem here, you're asked to melt a block of ice at its melting point, 0 degrees Celsius. That temperature is not given as a calculation help. That just helps you to see that it's a phase change, because temperature doesn't change. There's only one temperature in that problem. So this is a phase change. I'm going to label that. And remember, if it's a phase change, I now have another decision to make. Is it freezing, melting, or is it vaporization, condensation? This one is freezing. Therefore, I'm going to use the heat of fusion, and that's easy to see on this one because it gives us the heat of fusion. So my equation here is Q equals MHF. So the first one, let's look at what they give us. 0.3 kilograms is the mass. 20 to 30 degrees Celsius gives us enough information to calculate the change in temperature. Remember, we need it to be positive. So this is a 10-degree change in temperature. 30 minus 20 is 10. Doesn't matter what direction it's going, up or down, just make the change in temperature positive. And then it says how much heat energy is required. Heat energy that is added or released is Q. So we can start plugging in numbers. Q equals, now I don't want you to write what I'm writing right now, because I'm going to show you two wrong ways to do this. A lot of things that I see. Number one, people know that the mass is 0.3, but then I see a lot of this, right? If you look at this closely, you can see that something's missing. And the reason something's missing is a lot of people lack good algebra skills, which means you just carry everything down. The Q came straight down as a Q because I'm solving for it. Mass came down and I plugged in 0.3. This is our change in temperature. What happened to our C? it went away. It disappeared. So don't do that. Don't let your variables disappear. Here's what I also see. People know that the C can't disappear, so they go 0.3, but then they know they don't know it, or at least they think they don't know it, and they put it in there, and then they put a 10 in, and they proceed to try to solve that. You can't do this because you have two variables and you cannot solve this problem anymore. A lot of people do this as well, and they don't realize if you do your substitution step and you end up with two variables, you did something wrong. There is a C. C is specific heat, and people go, well, where do we get it? Remember, this problem is about water. Any problem about water, you're going to get those constants from the chart. So if you look in the chart, the C of water is 4,186 joules, the specific heat of water. That's the number we need, and so we're going to plug that in, 0.3. C is 4186, and the change in temperature is 10 degrees. Now all we have to do is multiply those, and you get 12,558 joules of energy added in order to accomplish this temperature change. That's easy. There's no algebra there. But you could be asked to solve for any of these others. Just be prepared for that. The second one, we decided that we're going to use Q equals MH. How much heat must be released? Now you got to be careful here because a lot of people read this and they go, oh, I must be solving for HF because it's a H for heat. That's not what you're solving for. Heat added or released is always Q. Q is what we're finding here. They give us the mass, and I also know I'm not solving for HF because they gave it to me. There's my HF. So this one, again, very simple, plug and chug. 1.2 kilograms times the HF of 230,000 joules per kilogram gives us a heat of 276,000 joules. That's how much heat it takes to freeze all that paraffin wax. And that's it for these.